The next protocol we're going to talk about in depth is IP version 6, or the sixth version of the IP protocol or the Internet Protocol. Now, you might say, well, we talked about IPv4, shouldn't we go to IPv5? And there really is no functional IPv5. We're going straight into 6, and we're actually going to make a little bit quicker work of this protocol than we did IPv4, because we're going to go into the assumption that you have an understanding of the services that IPv4 provides. So if maybe you understand IPv4 a little bit and decided to skip that section, you may want to review it just real quickly so you make sure you understand the concepts there, so that when we talk about them here, it'll make a little bit more sense to you. So we're going to assume while talking about IPv6 that you already know about IPv4. So we'll frame this in terms of what services are the same, what services are a little bit different, what fields are the same, what fields look a little bit different, and so on. But that will really help frame our discussion of IPv6. Now, IPv6 was created to solve the problem we discussed earlier about the limited number of external or public addresses available in the IPv4 space. And if you'll remember, an IPv4 address is only 4 bytes, and that gave us just a little less than 4.3 billion possible addresses. Now, when IPv4 was created decades ago, people thought, well, there will never be 4.3 billion devices connected to the public internet. That should be plenty. Well, sure enough, now that we have IP addresses on our toasters and our pressure cookers and our televisions and our phones as well, that no longer is the case. So we're running out of those public-facing IP addresses, and even with network address translation, which we spoke about, no longer are we free of worry from exhausting this IP address space. So IPv6 was primarily developed to answer this question, and of course some other efficiencies and changes came with that, but primarily it was developed to respond to this limited number of IP addresses. As a result, an IPv6 address is actually 16 bytes. And whereas the IPv4 address was measured in billions of IP addresses, IPv6 is measured in undecillions. How many times have you said the phrase undecillion? Probably not too often. I will say I only know it because I know that IPv6 is measured in undecillion number of addresses. So that shakes out to 3.4 times 10 to the 38th. So it's a lot more addresses to a lot greater degree. So again, we're talking about a 16-byte address space versus a 4-byte address space. And we'll talk about that a little bit more. I'll show some examples of those addresses, what they look like, how to write them out, how they're derived, and so on. Now, of course, IPv6 can be examined further in RFC 2460. We're not going to cover everything here, and there are a few facets of IPv6 that are probably interesting, but not the most practical. So we're going to talk about things like extension headers and how they work, but we're not going to cover every extension header. So RFC 2460 is a good starting off place. There are certainly other RFCs as well. All that said, the big thing to keep in mind is that IPv6, for the most part, performs most of the same services as IPv4. It's responsible for addressing of network devices. It allows for communication to be routed between networks, and it's ultimately an unreliable protocol, but it does allow for things like fragmentation and so on. So a lot of the same services, really functionally kind of the same, just a few different implementation mechanisms, a few different things have changed, and we're going to go through most of those here. You're looking now at the IPv6 header, and you'll notice that it's pretty similar to what you remember with the IPv4 header, but there are a couple of big glaring differences. Probably the biggest is that it's just certainly a larger header. In this case, it's actually double the size of a standard IPv4 header, and most of that is attributed to the larger space dedicated to the source and destination IP address, which are taking up a big chunk of the header that you see on the screen here. So once again, we're going to go through some of the more important fields to know here and how they function, and then we'll talk about stimulus and response for those things as well. Now, right off the bat, in the higher order nibble of byte 0, you see the version field, and this serves the same purpose as the version field in the IPv4 header. It's going to have a value of 6 for IPv6, and it's basically just so that the recipient machine knows that it's reading IPv6 data, so it knows how to properly decode and dissect that packet. Now, the next field I want to talk about is the payload length field, and this is different because remember we had the total length field before, and the total length field basically had the length of the entire packet minus the link layer header. Payload length is a little bit different because it's actually just the length of the data payload following the IPv6 header. So at the end of the header you see on the screen here, everything else, that's the payload length in this case. So it's a little bit different of a measurement. And of course, in this case, that starts at byte 4. So it's in that second row, and it's a 2-byte field. So you have that payload length there. Now, one thing I get asked a lot is what happened to the header length field. In IPv4, the very first byte or byte 0 was dedicated to the version and the higher order nibble and the header length and the lower order nibble, but you don't see header length here. And the answer for that is actually quite simple. The IPv6 header is always 40 bytes. Whereas an IPv4 header was minimum 20 bytes, and that's certainly the standard. You have the ability to add IP options in that could change the length of that header. And since it was a variable length header, you needed a field that told the receiving system how long that header was and how to process it. We don't have that in IPv6. Now, that's not to say we don't have options in IPv6. We do, but they're delivered through a concept called extension headers, which make use of the next header field. And we'll go through some examples of that here in a minute. But what you need to take away right now is that the IPv6 header at base is always 40 bytes, so you should always see the 40 byte header with the fields you see on the screen here.